the abbreviation for molality is a lowercase cursive m. Of course, molarity is the uppercase print m is molarity. So guys, you're going to have to watch, because now you can't just think of molarity as moles per liter and molality as moles per kilogram, because they're not interchangeable. Because molarity is per liter of solution and molality is per kilogram of solvent. Do y'all know what these different terms mean? What is this? Go ahead.
Solvent is the product.
The solution is the product.
Solvent is what you mix the solute in.
Yes, the solvent is what you mix the solute in, and together they make the solution. So for molarity, we're dividing it per, think of it as like a total volume. The solution volume is when the solute and solvent are together. But for molality, we're just dividing it by the mass of just the solvent. Okay, so they're different. Let's work a problem. Y'all, when you're working these kinds of problems, it's a really good idea to be sure you totally label everything. Don't just label it as grams, or don't just label it as moles, but make sure you know it's grams of what. Is it the grams of the solvent? Is it the grams of the solute? Is this the moles of the solvent or solute? Is it solution? Be sure you label everything, and you can catch some mistakes. You got to know what potassium nitrate is. Yes, you know it, John. Hang on. What's potassium nitrate's formula? Oh, good. So why did I need to know that? Because I've got to do the molar mass. I've got to convert grams to moles using the molar mass. So I'll give you guys a second to set that up. I'm going to start talking about some of what I've done. I've converted grams to moles. Okay. Any questions on where I got the 101.11? Just from the periodic table? Hopefully not. As I said a second ago, y'all look how I'm labeling everything. I'm not just leaving it as moles and grams, but I'm specifically writing, okay, that's moles of KNO3. That's grams of KNO3. That's going to be important that you label it, because when you introduce molality in about 5 minutes, you're going to see how easy it is to use the wrong number. Another thing that you've got to watch on these problems, to a certain extent, you've got to be careful about your significant figures. We all get a little lazy, and we do this calculation, and we write like 0.11 moles. That's a very bad thing to do. 0.11 has only 2 sig figs, right? If I look up in the problem, that 11.4 has 3 significant figures. That 250.0 has actually 4 significant figures, right? So why would I stop and get some kind of answer and round off to fewer sig figs than what my final answer is going to be? Okay? How many sig figs do I need in my final answer? 3. It's always fewer, right? This one's got 3. This one's got 4. I'm going to need 3 in my final answer. So the rule is you always keep one beyond what you're going to need in your final answer. Don't start rounding off here, because 0.113 is going to give you an even greater different answer, because we're not finished yet. Y'all follow what I'm saying? What do I need to do after that?
Change milliliters to
I've got to convert the 250 milliliters to liters. 250 milliliters is how many liters? 0.250 liters. And then what do I do? Right. I take the 0.1127 moles of KNO3, divide it by the 0.250 liters of solution, and that gives me a molarity of 0.451 molar KNO3. I would start off with what I'm looking for. If I'm wanting to calculate the molality, then molality is what? Right, it's moles of solute, which in this case, do you guys see the solute is the glucose? So I need moles of glucose divided by, what's the solvent in this case?
Water.
It's the water. Do you see that? So specifically, I'm looking for how many moles of glucose? Oh, shucks. That should be C6, not C2. How many moles of glucose I have and how many kilograms of water do I have? Where do you want to start? Okay, use the molar mass of glucose and convert grams to moles. Go right ahead. For my molar mass of glucose, I got 180.18. Is that what y'all have for molar mass?
Yeah, that's all I
Y'all use 12.01 for carbon? 1.01 for hydrogen?
I use 1.0.
Oh, okay. Okay, that's fine. It's not that different. So for moles of glucose, 0.9441, is that right? 0.9441 moles of glucose. So that, can I keep going? That gives me, I'm going to go back to over here, the top number. I know I've got 0.9441 moles of glucose. How much water do I have? I'm not told exactly how much water I've put in there, am I? I know that once I add the glucose to the water, together they're going to make a liter. But I need to know how much water I put in. Huh? Can I reverse the density? How? I need the mass of water. What you going to do?
Isn't the mass of water the same as, isn't 1 gram of water the same as 1 milliliter of water?
Yes. A gram of water is a milliliter of water.
But that doesn't mean that.
Right, because this isn't pure water now. I've put glucose in it. I know density is equal to mass over volume. What would you do with that?
The density is 1.062.
Okay. I know the density is 1.062. Here's where I want you to be careful. What is that the density of? The solution. That's not the density of the water. That's not the density of the glucose. 1.062 is the density of the solution. Why are you telling us to be careful? Because that means if I'm going to use that number for density, then over here, that's mass of solution. This is volume of solution.
So if you use the mass of one of the solvents, could you define?
You can't use the density of the solution and the mass of the solute. You see what I'm saying, guys? You got to be careful. That's why I said be sure you label things so you don't let that happen. But yeah, we're going to need this formula. We're going to need the 1.062. Is there anything else we know about the solution? Yeah, we know the density of water will be 1, but we're not going to need that.
You have a liter of solution.
We know there's not a number, but it says that I have a liter of solution, doesn't it? So I know the volume of the solution. If I know, yes, if I know the density of the solution and I know the volume of the solution, then I can figure out the mass of the solution, and I know that the mass of this solution is 1,062 grams. Do you know that?
Yeah, because you're.
Could it be gram per liters instead of gram per milliliters?
Well, if the density is 1.062 grams per milliliter, and I have a liter, well, that's 1,000 milliliters. Yes? So this density, 1.062, as my density, times my volume in milliliters is 1,062 grams. I mean, you can work through all that in your head, or you can write it down and solve for it in the formula, okay? 1.062 grams per milliliter is equal to the mass divided by 1,000 milliliters. Where did I get that 1,000 milliliters from again? Did I just pick that number? I got it from the problem because it says a liter of solution. So you can't just pick 1,000. We got it from a liter, and a liter is 1,000 milliliters. So are you with me now on 1,062 grams of solution? Okay. Tell me again what we're trying to figure out. The molality, and in order to finish solving for molality, I need kilograms of water. What do I have? Essentially I have kilograms of solution, don't I? But I just need, can I figure out how much water is in that? If I subtract out the 170.1 grams of the solute, then won't that tell me how many grams of solvent were there?
891.9.
I'm sorry, you're going to have to say it again.
891.9.
891.9.
Big 0.89 kilograms.
Right. Is everybody okay on what I just did there?
Divide by 1,000.
Right. I take the grams, make it kilograms, which is 0.8919 kilograms, and I put that number over here. 0.8919 kilograms. What do y'all get for molality? 1.06?
Do you not do that for significant figures?
Yes. 1.058.